Okay, so what's wrong with this one? Oh, they're all good. They're all good. Do you know what I meant? They're all good. It's like no charge. We're all good. But you should know there are hydrogens that haven't drawn. Okay, this is a very special one. How about we do? I know you should do that in week 2. What's the hybridization of all the carbon?
SP2. Wait. SP2. Is it SP3? Because the hydrogens are visible.
Even you draw the hydrogen, they're all sp2.
Oh. Well.
See, they're all. Every carbon is on a double bond. Look clearly. Every carbon is on a double bond,
Right. Yeah.
which means they're all sp2. Okay. On your discussion menu, the way you draw this, that's why it's an easy one, because you just keep pushing. You can do within it, or you can do like a other way. You just keep pushing. Basically, they're all sp2, but I will explain in a different way. So there are many ways of doing this, and you can draw a bunch of that. There are no charge change. You just keep changing the double bond place until you see you meet the requirements of all carbon has sp2. It's like all carbon is one single bond and one double bond. You can see all the carbon is one single bond and one double bond. You can write them in a different way. Okay, let's do this one. Okay. That will push this one here, right? So I did not change the other part. Okay, I did not change the other part. So the other part was still like this, right? Okay, but you can still keep moving. This one you can draw a lot, but okay, you can keep moving. Okay, you don't. Am I good? Just don't show this one because it's kind of like the same on this side.
Yeah, I think my question was like, how am I supposed to draw all the variations of this?
In this case, you just keep going with finish that we would count all the possible drawing. I know you guys are too worried about did I draw all of them. It's kind of like we set the question to draw all of them. We meant to ask you, do you know you can keep moving? Not meant to say like, okay, if I stop here, or I kind of like, we meant just to show you the point of asking you to draw all is you should know you can keep moving. They're not only one. So that's the point of that, okay?
So then, is the technique kind of like you just draw the arrows within the same like circle around the circle, if that makes sense?
This one is the case because it doesn't have any charge. The real fact of the resonance in this case, okay, which I'm not sure if will be, do I have enough, but I'll try to see if we can do this.
Should there be I think there shouldn't be a double bond right there. The black. Right there?
Here?
Yeah, right here. There shouldn't be one.
There should, oh yeah. Okay. Yeah. Okay. I cannot. Okay, that's too rigid. That's too fragile. That's okay. Not sure if you can see this. So that's the point of this would be. Okay, the point of this would be there's bond. There, I meant to say this is a bond, double bond to this, but I'm running out of that. Okay, the point of this resonance, all of the carbon is sp2, right? So they're on the same plane. sp2 is plane, trigonal plane, right? Which means the hydrogen is here if this is double bond here, if this is double bond here, right? Okay, so, okay, let's do this way. Each small short one, okay? Each small short one, okay. I'll try to not drop this, otherwise we'll, okay. Each small short one is an electron. And then it's formed bond between this, it's formed bond between here, and between here. But the next second is formed bond between here, and between here. Is that clear? That's the fact of showing those arrows, is you breaking this bond and forming here, then you will have to break this bond because this blue is already forming bond with this green. You will have to break this bond and forming here. So that's the key points of resonance. It's just this single bond, double bond keep changing.
I was also wondering, why can't you make the double bond into a lone pair and then add a charge? Because isn't that a reasonable resonance?
Okay, that still works. So like this, I will still count like this, right? Then this is positive, this one has a negative. I will still count that's correct. But it's just in this case, which, well, you will learn this more in chapter 15. They tend not to do that.
Okay.
Yeah. Then in this case, if you just care about your quiz, that's a correct structure. But for a stuff you haven't learned yet, they don't want to do this.
I feel like when I was doing the problems, I noticed you move the bond to be a lone pair if there's like a charge existing. And if there's no charge, you just move the bond to another bond.
That's not always the case. It depends on case to case.
Okay.
Yeah. So this one is an aromatic compound. Aromatic compound wants to keep this. So don't you feel it's really beautiful when each of them have a p electrons standing out? So what in reality, what happened is only if they are plane, only if they're on a plane, and each of them has a p electrons, this electrons is going to form something like, they just want to stay like this. So that's why when we draw resonance structure of this, we don't form that charge. But it's fine if you really form that charge, okay? It's something you will learn in chapter 15, aromatic. It's like they want to stay in this way. Yeah, basically it's in chapter 15, your instructor will show you a very similar model of this, and you will see all p electrons is pointing out. Yeah. And this is going to form, like, don't we say electrons can form a magnet? Like, if you have taken physics. So electrons generate magnets. Are we good? Okay, assuming you know this. There is actually electrons flowing this, and there is a small magnet pointing up or pointing down in this special case. Okay. Don't worry, you'll learn this in discussion 6. Okay. Yeah. You have more things to learn, right? And don't want to scare you guys too much, but organic chemistry kind of like we teach you something in chapter 1. You will go back to learn this in chapter 5 or 6 or later. Yeah. Yeah. Okay. Don't worry too much by now. I feel like I didn't comfort anyone. I'll stop the video.